We've been looking at matrices, right? And so far, what we did is we compared them to what you already know, and we looked at processes for how to solve systems of linear equations. Do you remember that? Remember that? Systems of linear equations. Okay. Now we said you can use a matrix, right, an augmented matrix, to solve a system of linear equations in exactly the same way that you're used to working with simultaneous equations. But we introduced this idea of row operations, right? How you can manipulate entire equations at a time, sometimes a whole bunch of them, okay? So this is kind of something you already knew how to do, taking a new tool and applying it to an existing problem. What we're going to start doing now is see how the new tool can let you deal with more complicated new problems, okay? So we're moving away from the older stuff. So to begin with, rather than give you all the theory and the processes and the algorithms for dealing with what you've got in front of you, I'm going to give you an analogy. It's about sushi. So, make a little subheading for me, okay? Now, I'm interested in calculating my sushi profits, okay? That's really what this is about, okay? So, let's just suppose, I know the school canteen, it sells a few different kinds of sushi. Let's push it up a little upmarket, right? 3 different kinds, just for the sake of simplicity. I'm going to make them, let's see, like, teriyaki chicken or something like that. Eel, which is my personal favorite. I don't think we're upmarket enough to sell eel at our school canteen. And then what would be a cheap option? Something vegetarian, I think, would be a bit cheaper. Okay, so 3 forms of sushi, and of course, because they've all got different ingredients, they cost different amounts. Okay, so I think sort of a standard price might be like $3. For your more classy one, eel's more expensive. You might have to pay an extra $1 for that one. And if there's no protein in it, okay, we'll give you that one for a little cheaper. Okay, so now I have some prices. Now, to work out what my profits are, right? Or maybe I should just say total sales. I want to know how much I sell, let's just say over a week. Okay, just over a week. So if I had for myself some Monday information, Tuesday, Wednesday, and so on. Okay, if I knew how much I sold each day of each of the kinds of sushi, right, then I could work out what my total sales and then for what my profit's going to be. Okay, so I guess I need to know not just for each day, but I need to know like the individual ones. So I'm going to have my chicken here, my eel, and my avocado ones here, right? Now, so that we actually can work with this and get some concrete numbers, I've made up some data, okay? So not only have we got these prices, but let me show you how much we've sold each day, okay? So, here we go, here's some information for you. Sorry, that's a bit wonky. There you go. Okay, so here we go. I've got some data now, and I can work this out. What would be a nice logical way to go about this? Okay, so I'm going to make a new sort of space over here. How would you go about calculating, if you wanted to, like, say, set up a spreadsheet to do this for yourself, and you're not going to use a calculator even though the numbers are relatively small, how would you do this in a logical way? Okay. Well, I would suggest maybe we go through day by day. I think that's a normal way to go about it. Okay. So let's say sales for Monday. Okay. How much are you going to work out as your total amount? Okay. Now I'm going to do something a bit unusual. Rather than write my first line of working here, I'm going to ask you to leave that first line of working empty for a second. We're going to fill something in there in a few minutes. Okay. Let's just start on the second line. How would you work out your bottom line for Monday? Not a trick question. What would you do?
I think I would do like 6 times 2, 8 times 4, 13 times 30 times 4.
Good. Okay, so what we're going to do is, in case you didn't catch that, right? We're going to match up these quantities with these prices. That makes sense, right? And then you multiply through and you should be able to get a total. Okay, so we're going to do 2 things. We're going to multiply and then we're going to add. That's not complicated. Let's just write that down. I'll go from the top. So 13 times 3, that'll give you your chicken sales. 8 times 4, that'll give you the eel sales. And then lastly, 6 times 2. Okay, these numbers are small enough, we can deal with this, right? 39, 32, 12, let's see. 39 plus 12 is 51, plus 32, that should give you $83. You okay with that? So far so good? Okay. Now this process, getting the sales for one day, is exactly the same for all the other days, right? So can I give you like maybe a minute or so? We've got 4 left to go. Can I get this column over here? Can you guys do Tuesday? Can you guys work out the Tuesday sum like this? Can you work out Wednesday, Thursday, and Friday over here on the right hand side of the room? Can you do that quickly? And then hand me your numbers when you're done. Oh, that's the first one. I did that No, as in like they're all Okay, that's enough time. It was just a simple calculation, so let's get some numbers out. Okay. Shh. What do we got here? Tuesday, total?
63.
63. Wait, 63? Yeah, good, cool. All right, Wednesday, 37. Next day, 75, good. And end of the week. What did you get for Friday? 21? Yeah, it was a bit of a slow day, wasn't it? Okay, good. So let's have a look at what we've done. This operation that we've done, right? I want you to notice a couple of things. It took in 2 tables of values. Can you see that, right? Here's table number 1, right? Here's table number 2. And what it output was a 3rd table. Okay, does that make sense? So what you have done is actually take 2 matrices, that's all tables are, right? You've taken 2 matrices and you have done a kind of multiplication to them, right? It's kind of taking everything and then getting the sums of it all, right? So how do we write this in matrix notation? Here's the way we do it, okay? What you've done is, here's your first matrix, okay? So you've got 3 quantities. And I'm writing it like that, okay? They represent 3 different variables there, okay? And then you've multiplied by, and now here's your set of data down here, okay? So here's our table. Okay, now what was the result that we got? This was our result down here, right? Oops, that's a bit close together, but you get the idea. Okay, so we need to put a name on this because as you can see, right, like this process that we walked through, in some senses, it was arbitrary. Like, why did we add the things up? Why not, like, say, take a difference? Or why did we multiply down this way and not across that way? In some senses, it was arbitrary. So this is really one kind of multiplication, right? And there are lots of different kinds of multiplication. So, for instance, this one here, and it's named after the symbol. This is called cross multiplication. You're like, what other kind of multiplication is there? And the answer is, well, you've already done one. It's this kind up here. This was a different kind of multiplication, right? Again, you were taking two matrices, right? In the first case up here for Monday, you took this matrix and you took this matrix, right? They're still matrices. But when you multiply them, you just got a number at the end. Okay? So we want to distinguish between these two. Some kinds of multiplication, you just get a number. Other kinds of multiplication, you end up with another matrix at the end, right? So how do we write these in different ways? Well, this one up here, and this is what you can put in that line. Okay, and this will start making sense of some of the things you already know. We want another symbol for multiplication. You guys already know another symbol for multiplication. It's a dot. Okay, like so. So again, I was multiplying two matrices. I suppose I could put that vertical. It doesn't really matter. This up here is called dot multiplication, or a dot product. And they're different. Okay? Because what you've ended up with at the end is just a number, right? Do you remember I told you a bit of a funny word for this? It started with an S a couple of lessons ago, right? When you've got things that are just numbers, they're not matrices. We call them, yep, scalar. Very good. So this is called a scalar product or a dot product. Okay? Whereas this is called a cross product. Or if you want to get more technical, but I'm not going to go into the details of why at the moment, it's also sometimes called a vector. Oops. A vector product. Okay? But we're not going to get into vectors. It's a big can of worms. Even though it's really cool, we don't have the time for it at the moment. Right? So, this is how you multiply matrices together. First, you work out these dot products, these scalar products. And in this case, there were 5 of them. And then you put them together and you get a matrix.